Hello, I'm Natalie Morrison for Informed Technologist. I'm at Interphex in New York, where Malvern, Schenck Accurate, Sturtevant and PSL have launched their new contained milling suite. Michelle Frisch from PSL told us about how the technology works.
How this works is this system is designed to provide the clients with high containment, which means we can get down into the low nanogram levels, which prevents exposure to the operators. It also gives the added benefit of in providing an environmental condition for the powder that's actually being processed in it, which is very key, because sometimes the powders can be hygroscopic and they can be sensitive to moisture. This is a nitrogen purge system which actually has less than 1% RH, so that provides a nice environmental control plus the operator control without having an exposure. So what happens is this system was designed very specifically for a certain client, and they wanted to be able to do certain functions in this isolator. So we went to other clients who could do those kind of systems that they wanted, such as a feeder, a micronizer, a particle analyzer, and then dispensing, that product.
Speaking to us about the partnership, as well as the online particle analyzer, which is Malvern's part of the technology, Jeff Denegris said,
the part of the technology we're using today is called the Incitec, which is a inline particle size analyzer. So we're monitoring in real time the particle size distribution of the material as it's flowing through the system.
And are you providing this as a service, or are you installing the machinery in labs?
We don't do the installation per se. What we're offering is the engineering to integrate the systems together. And a large part of this, other than the stainless steel and the piping that you see here, is the work behind the scenes, and that's really the software that drives it.
Ashin Nayeri from Schenck Accurate told us about their feeder and how the deal came together.
Schenck Accurate provided the AP300 feeder, which is a volumetric single screw feeder. The feeder uses flexible wall technology, and basically you introduce your powder at the top through this hopper and goes down into the flexible wall. Flexible wall will knead the material and help the material pass into the helix. And then the helix will turn and move the material out. And this is done volumetrically, which is typical for milling applications.
Now, you was also involved in the overall business development of this deal. I mean, obviously it's quite unusual to get 4 companies working on one project.
Right.
Why have you chosen to work with 3 other companies of this?
A lot of times customers can't see how equipment can be brought together to really bring value to what they're trying to do. In this particular instance, the system that is here has a huge advantage for R&D. Now, if you really think about it, in most applications, you're going to have a customer that is going to be taking and milling a product in a batch at different rates, and when they're done milling that product, they're going to send it out to another team who's going to analyze it. From what I've heard, it usually takes anywhere from 3 weeks to 2 months to get the results back. So you've got all that lag time that you're waiting for results. And if the results aren't what you want, you have to go back and start over again and wait another 3 months for the results. With this system, you have everything you need to give you the analysis immediately and get you the results immediately. So all you really have to do is have enough material to get started and then make your product, and that's it.
Joe Muscolino from Sturtevant spoke to us about the micronizer and the importance of making molecules smaller.
So the intent of the micronizer is to take a powder that's already in large size, like a grain of salt, and through a series of high pressure compressed air, accelerate the powder so that it impacts against itself, and basically it shatters itself down to very low micron size, on the order of 1 to 10 microns, or talcum powder size, if you're familiar with talcum powder size.
And making the particles smaller, what is this so you could
What's the benefit?
Yeah, what's the benefit, basically?
There's a number of benefits. One benefit is that if you take a particle and fracture it into a smaller size, more surface area is exposed. And if you fracture it into finer and finer sizes, the surface area that gets exposed dramatically increases. So what that means basically is that you can get more use of the same particle if you can make it into a bunch of smaller particles by exposing the surface area. The other big benefits is that in the pharmaceutical industry, where a grain of an active ingredient, if it's a certain size that's too large, and combined with other smaller sizes, you can give the patient an overdose because you've got one large grain of an active pharmaceutical ingredient and a bunch of smaller ones. So the purpose of the micronizer is to take this particle and make it into a bunch of much, much smaller, uniform, tight particle size distribution particles, so you can predict the reaction of these particles. So you don't have a bunch of small particles and then a few big pieces that are going to throw the formulation out dramatically. So it's continuity, consistency, and being able to predict how these pharmaceutical compounds will react in the human body.
I'm Natalie Morrison, the Informa Technologist. Thank you very much.